Hello, everyone. Welcome to the session. Today, we'll be talking about over-the-air updates and how to get these devices updated using the Azure Device Update. From Microsoft, I'm Wellington Duraes. I'm a PM on the Azure IoT team.
And I'm Ewerton Scaboro de Silva. I'm a software engineer on the Azure IoT CSDK team.
Awesome. Today, we'll be talking to you about how to do over-the-air updates using the Azure Device Update. And for that, I have a diagram that explains a bit more in details on how this process will happen. Here we're showing two things. First is a device, an IoT device, and also in the other side here, we have everything that's inside Microsoft Azure. And the Azure ADU service will be connected both with the blob storage and also with IoT Hub, from which, with this connection, it would allow it to manage all of the update files and the manifest files. And the connection with the Hub will allow the service to trigger updates and to show process updates. Now, on the device side, what we have is a combination of the free RTOS middleware and the embedded CSDK, both components provided by Microsoft. And then when this device is connected via MQTT using an MQTT client, it will get notified by the service, ADU service via IoT Hub, that say, you're running version 1.0, and then the service will say, hey, you need to update to version 1.1. Then we'll be, so using the libraries that we're adding to the FreeRTOS middleware, we'll be parsing that information, making sure that this update request is coming from a trustworthy source. In this case, we'll be checking if this is coming from Azure. And then the user application will be able to open up an HTTP connection, connect to the blob storage, download all of the bits, check if these bits are fine, and then installing that in one of the memory banks. In this case, we'll be showing you today how to do that using an ESP32. And the ESP32 in this case, it is very unique as it has a lot of space for us to use, but mostly what happens is we're gonna have our sample installed in one of the partitions, say OTA 1, and then using the over-the-air update, we're gonna be writing the new version of the firmware to the second partition, and then the OTA data will just be pointing to this newer version, which means that we are not deleting the previous version that we have here. So in this case, if something goes wrong, you can always revert back to the previous version. Another thing that is very important when doing this is to make sure that you're using, you have your credentials stored in a non-volatile storage, meaning that all of your credentials for both Wi-Fi and IoT are stored here, so that your firmware will be looking at these credentials here, meaning that every time we can have updates as much as we want on the banks OTA 1 and 2, and these credentials living here won't be erased. All right. And with that, let's move over to Ewerton so we can take a look at the process and how the libraries that we have will help you do this update.
All right, thank you, Wellington. Yes, so as Wellington has mentioned, we have this new service to help with over-the-air updates called Azure Device Update. And we are exposing the APIs for C applications to use the service, so customers can execute updates on their devices remotely. And I'm going to just give an overview of how it works, the whole design works, and also start with one of the samples that we have available right now. So we have here on the screen on Azure portal, we have my own personal IoT hub. And here now there's this new option, which is updates. And with updates, you can generate an image and associate that image with a deployment. And this deployment is then associated with a group of devices. So these devices are going to then receive an update request and will process that update request and send back statuses back to the portal, to the IoT Hub and the EDU service. So the service knows if the updates are completed or not. And that way you can update your whole fleet. And here we have an example of an update that I've already performed. And I'm going to just show here. This has one deployment that has already succeeded. As you can see here, on latest update, there's one device. And it's this device here called OTA SAS6. It says that it's already on the latest update that I've created, that is the 1.1. It was originally on 1.0 and then 1.1. I want to show quickly what we have here in terms of how this request goes down to the device. On IoT Hub, there is a messaging feature called Device Twin. And that is a way to keep properties synchronized between devices and the cloud. So there's always a synchronized set of property bags that the device can use. And this is what is used for the updates. There is a request that goes down to the device that is sent here. And this update information is going to give details of how the device should proceed to download that image, apply the image, and how to refer back to this deployment to the service so it knows that it has completed. And an example here is how the device informs how in which stage it is and how the deployment has gone. Here we can see that state is 0, which means the device is now idle in terms of update, and the current version is already 1.1. So this is for a previous device that I've already updated, and that shows how the communication works. Tying this all together, it all comes back to the view that you have here with the status that is provided without you having to dig into the device twin. It's just an extra information for understanding how the process works. And I would like to show you the sample that we have implemented for FreeRTOS to use the new ADU, the Azure Device Update API. Here we have a sample that is implemented on the ESP32, how Wellington has described. And I'm going to go straight into the page that has the documentation here. Let me go to Espressif. As soon as we get to GA, this is going to be available on main. For now, we have ADU. And here we have a complete description of all the steps needed for anyone to be able to get from 0 to a complete deployment on a ESP32 to use as a sample for a possible implementation. And I'm going to just start with like the basics of how that it's done. Once we've cloned the repo, which is that same repo that I showed, we have to navigate to the sample where the directory where the sample is. And we are using here configuration to be able to provide the sample with information like, for example, how to connect to your Wi-Fi and what is your IoT hub and your device ID. And to provide this configuration, we're using the standard way of that is used for the samples in the ESP which is using menu config. So right here, I'm gonna run menu config. And it goes a little faster because I've built it before, but it usually takes a few seconds to get there. So we have two sets of information. One is going to be the Wi-Fi information that you need to run, to provide. Here I'm using a generic Wi-Fi spot that is just with a generic set of password, user SSID and password. And just to remind that these boards that we're using, the ESP32, they need a 2.4 gigahertz Wi-Fi connection. So a 5 gigahertz connection will not work. So once these are provided, we go back here to the information we need to provide in terms of what is your IoT hub and device ID and the authentication method. So I'm going to provide the information that I have for IoT hub Ewerton's, which is my own IoT hub. And I am going to provide the other details for this device, which is that I'm using here, OTA SAS 6. So I'm going to copy this. I'm going to insert this information here. And for these samples, we're using symmetric keys for authentication. Authentication can also be done with IoT Hub through X509 or even using device provisioning. But for this sample, we're keeping it simple and using SAS tokens. And for that, we use the primary key for the generation. So once these are provided, we can save that information into a file, quit, and then we go ahead and build our solution. Build usually takes about like 2 minutes, 2.5 minutes to complete on my machine. And in this case, it's going to run a little faster because I've also built it previously. So most of the components are already pre-compiled. I thought it would be faster, but looks like it decided not to. All right, so now that the bid has completed, the next thing we need to do is to flash this image of the sample into the device. So just to give a little more clarity of what is going on here. When the sample is compiled for the first time, the version that is hard-coded in the sample is the version 1.0. So if when you follow the steps on that guide that we just showed on the page, you will see that you first will flash your device with version 1.0, and then it will generate a second image with version 1.1 or the following. And then you are going to use Azure Device Update to trigger the update to the device so it can consume that request and update itself. So here I am connecting one ESP32 based board, which is the Azure IoT Kit. And after verifying on Device Manager, I see that this device is connected to COM5 port. So the next thing I'm going to do is just flash this device, and I'm going to monitor it as functionality. So here, the rest of this process actually can be seen on a video that we have available on YouTube that shows we going through all the steps on the guide that is also on the samples repo. And you can see how this whole thing works from beginning to end, with the device connecting and updating itself. And what we're going to do here is I'm going to turn back to Wellington, and he's going to show another project that he has done that shows this in a much bigger scale, not just with one device. And that's going to be pretty cool. Wellington?
Okay, thank you, Ewerton. So for this demo, what I'm going to be showing you is this set of 8 ESP32 devices. They're all the same model. So this is a design that I did for this board. These devices are divided in 3 groups. One is the test lab, the second one building 17, the third one is called San Diego. They are divided like this. So I have a lab group, which is running the firmware version 1.7. Building 17 group is already updated to version 1.7. And then what we're going to be doing is updating the San Diego group, which is currently running version 1.6. So as you can see, is one version behind. And the way we can tell which version each device is running is that all these devices have 2 LEDs, one yellow and one blue. So the current version, which is the previous version, which is 1.6, it turns the blue LEDs on. And as soon as these devices get updated and they get the new version, which is 1.7, they will actually turn the yellow LED on. So we can visually see that these devices are now in a different version. Also, as you can see here, I have only 3 devices within each of these groups, but you can have many more according to your needs. And most likely, this is a scenario that will be happening in real life as well, in which you would first deploy your new firmware to a small controlled group of devices, make sure that everything is fine. And once you can validate that's fine, then you can start deploying it to the next group and to the next group and to the next one. So you see that everything is fine. But don't worry, if something goes wrong, you can always revert it back. You can always downgrade these updates on the devices. Let me show you the real devices. All right, so in this camera view, you can see all of these devices. They're right here by my side. So as you can see here, the test labs devices, both of them already have the yellow LED on. The building 17 also have the yellow LED on, and you see here that the ST02 and 03 both have the blue LED on. I just had a small issue with the ST01, so for now it is unplugged, but I can still show you this working with 2 devices. Let me move now to the ADU portal to show you how that works. Okay, so now we're seeing the same window that Ewerton was showing before. However, here I have all 3 of my groups, the lab group, the building 17 group, and the San Diego group. Also, you can see that this first group here, it has 2 devices and it's already on the current deployment, as you can see by the last column, which says current deployment. Same thing goes to the building 17 group, is also on the current deployment. And you can see by this chart on top here that shows the green part saying that 5 devices are already on the latest update and 3 devices still need to be updated to the latest version. So what we're going to be doing now is deploying. So I'm going to hit deploy. When we do that, we have the option of start this update immediately or schedule this update to happen in a certain sometime in the future. So in this case, I'm going to go and hit create right now to start this immediately. And with that, we will revert the camera now so we can see what's going on these devices. All right, now let's take a look at what's going on here. So I hit the deploy and deploy now. And as you can see here, this is the terminal looking at one of the devices. That's one of the devices. And it was showing previously the version 1.6. So remember, we asked it to update to version 1.7. So what happens here is once we start the update process, the device will get the twin patch saying that, hey, this is the new desired version of your firmware that you need to update. So it gets all of this information so that it will verify if this manifest is the JWS manifest to see if the signature of that is a good one. And once it does that and it makes sure that the is SHA-256 for that matches. So what it does is accept the update request. So it will create the HTTP handle for that. It will download all of these packages. So just breaking the download into smaller chunks, so to make it better to use. We get the whole image, we assemble it back, we check the hash once again, this time for the image. Once that's completed, so now we're good to start saving this update in a different memory bank. Once we have that, the device boots up, and then it would wake up, get the credentials, and voila, it's already showing that it's on the version 1.7. So if we go back now, to the ADU and I hit refresh, what we'll see is that now 7 of the devices are on the latest update. And yeah, if I click here to bring the devices again, you see that, yeah, that makes sense. One of the devices that is off camera is already updated. And I also have here, as you can see, this device here in the middle is also with the yellow LED on, meaning that this is also updated. And we have only one missing right now, which is the ST03, which is absolutely normal. So the service won't, once you hit deploy, it won't just send the same information down to all of your devices, because we don't want, a massive amount of devices trying to stop what they're doing, trying to get the bits and then upgrading. It will actually wait a couple of minutes, so we will send the messages to the different devices within the group with some time interval between them, right? So this is absolutely normal. And as you can see, 2 of these devices are already updated. All right, with that, we end our presentation. So the call to action for you is, if you have an ESP32, please go ahead and try the sample. You will find the description here below on this link that takes you to the ESP32 sample for over-the-air update. And please let us know if you or your customers have questions or if you need any help. You also can file an issue or send questions for us on that GitHub repo. And with that, we end our presentation. Thank you for your time. Right, Ewerton?
Thank you, everyone.
Thank you. Bye.
Hi, I'm back, and now I'd like to invite Wellington and Dane to join us for the Q&A session. Hey guys, how are you today?
Good. How about you, Pedro?
Actually, it's good morning for you.
Mm-hmm.
Yep.
Yes, it is.
I mean, so we have one question here. So when ADU will become available? So that's
good question. Yes, so the service is already available. That's from the cloud part, from the Azure service is already available. Our library, which goes along with the free RTOS middleware, is currently in preview. So as Ewerton showed, it's still living on a separate branch. It's not part of main quite yet, but hey, it's open. Anyone can take a look at that. As all of the things we do from our team, it's open source and it is free to use and modify and do however you need to change it. And it will become GA, meaning it will be incorporated to main in a month. So we're close to that.
Okay, so it'll be ready for like commercial use.
Exactly, for production scenarios. Yes. Yes. Right now, what's live, it's not really meant for production scenarios because it might change a little still. But yeah, in a month, it will be good to go for production scenarios, so folks can, I don't know, maybe design their own circuits, and have over-the-air updates go into their ESP32s.
Yeah, I have one more question. We had this morning here in Europe, a talk about the component manager. And do you have any plans or ideas about like adding the ADU into the component manager.
Yes, and actually not only the ADU, because ADU is part of a bigger strategy we have for the Espressif chips, right? So it will be more than that. It will be the FreeRTOS middleware we created. So FreeRTOS middleware is just a, kind of a set of libraries that you can add to your FreeRTOS implementation, and will make your ESP32 to connect to Azure and all of the Azure services. So yeah, it will be part of that.
And I'm curious about the development board you are using. So it is open source. Can you tell me a little bit more about the board that you are using? Because this is the first time that I'm seeing. Okay.
Oh yeah.
Yeah.
So the thing is, we from the team, we needed some device to test what we were doing. And personally, I don't like to work with simulators, right? So if I can have a real sensor, I would rather go with a real sensor than with simulated ones, right? So we took here, cheap temperature humidity sensor with the DHT11. I added, so there's an LDR here, so a light sensor, a buzzer, NeoPixel, that kind of stuff. So really, really basic sensors. So we could have not only one, but as you can see here, that I still have those, right? So I can have a bunch of these devices manufactured. I can build them myself, leave them all on, so I can always test what we're doing. So every time Dane comes up with a new version of the ADU for over the updates, I can run this on all of my devices. So yeah, I don't have this published anywhere, but I can. It's a simple design. Yeah.
Nice. And is there any other like update or roadmap that you could share with us? I know from the talk, but do you have any news since the talk?
Yes, actually we do. So because we know over-the-air updates are so important for so many IoT scenarios, and also we know that not everyone is currently using FreeRTOS. So we know FreeRTOS is super cool, but not everyone uses that. So we're also bringing the over-the-air capability for the ESP32 using Arduino. Right. So if you use Arduino, I don't know, I don't want to get into FreeRTOS, it's too complex. It's okay. You can use the ESP32 libraries for Azure on the Arduino, and it will also get over-the-air updates there. So it's much better.
bare metal scenarios, you can import the Arduino library, and then we'll have a sample there for people to use as well.
Nice. And when you say like ESP32, it also includes like S3, S2, C3 eventually, and any other like family that we have currently.
It should work. Honestly, we test, and in our lab we only have the ESP32, right? That's the only one we are testing with. Nothing should prevent it from working on the other ones, especially given that most of our libraries they don't do I/O. So our libraries would require external MQTT client and TLS and socket connection anyway. So it should work. It's just that we don't test for them and we don't have specific samples for that yet. That's something we might need to work on the future, Pedro.
Yeah, we have one comment here from Thiago. One common problem when you have thousand devices installed, it's to upgrade them, but not all devices can be updated usually, or you have to take care to update the device during a no critical activity. So this is like pretty cool comment.
Yeah, and actually on that point, so the last point about the update the device during a non-critical activity. So what you can do on the device is essentially read that the service has an update for the device, and the device can choose when to apply that update. So the basics are there, so the endpoint, the verification, and you can send a response to the service saying, I accept this update, I verified it, this is an update that I want to take. But I'm going to off-put it when, let's say the device isn't under a huge load. Maybe it's late at night or whatever the scenario is. So the user can actually take advantage of updating it when it's best for that device specifically.
There's one more question from Thiago. In ADU, can you classify the equipments in different groups and manage different versions?
Yes. So you can group your devices with a handful of tags. So you can have a certain, let's say, a certain set of ESP32s or whatever other devices you have. And let's say the devices are specific for different boards. You can group those different boards into different update groups and deploy the updates to those groups separately. And even if let's say the boards are the same type, but they're getting different updates or they're in different areas, you can deploy those separately. So you can group your devices however you want based on tags, which we should have in our README in our instructions.
That's a great point. Yeah, as you can see on the video too, right? On my device, on my sample, which I have these two devices in a group, this device in a group, this device in another group. So I could, define what was the best time to deploy to each of these groups. In this case, all of these devices were the same, so same firmware for all of the devices. But yeah, as Dan said, you could have different groups with different types of devices, and so you have different firmware upgrades going to different devices. But yeah, great question, Thiago. Thank you.
Okay. And I think we have time for one more question. And how can ADU integrate with the new announced Matter 1.0 specification? Or are these compatible schemes?
That's a good question. I'm no Matter expert, but I can tell you right now that the protocols that ADU is using, as you could see on the video, will be pretty much the device connects using MQTT for all of its basic connection with the cloud and notification and things like that. And it's using HTTP to download the firmware image and things like that. So it's to say that it's kind of a different approach. It's not to say that we won't ever look at Matter, because we know it's getting more and more popular. But currently, this is how the service works.
Great. Okay, so I'd like to thank you for the talk and being here for the question and answers. So have a nice day.
Thank you. You too. Everyone else. Appreciate it.
Bye.